Today we're going to talk about the domain and range of word problems. Just a reminder, domain is your x values and range is going to be your y values. You need to get out your interactive notebook and go to your words worth knowing and put in the next two words, discrete and continuous. In order to find the domain and range of word problems, we're going to have to determine if the data is discrete data or if it's continuous data. So in your words worth knowing, you're going to write discrete. The definition of discrete is data that can be counted. It's only whole numbers. Continuous data is data that is measured. It can be decimals. So if something is discrete data, it can be counted. It has to only include whole number values. Continuous data is data that's measured, and it can be whole numbers or decimals. In your graphic organizer, we're going to talk about the difference between discrete data and continuous data. Discrete data, as we said, can only take on certain values. They have to be whole numbers. Continuous data can take on any value within a range. As I stated earlier, it can be decimals or whole numbers. Discrete data is counted, while continuous data is measured. Discrete data, when we write the domain and the range of it, is in set notation, which is these squiggle marks on each side, as where continuous data is written in inequality notation, or like what we like to call sandwich inequalities. Examples of discrete data are the number of chairs. I cannot have part of a chair. I can only have whole chairs. So the number of chairs is discrete data because I have whole numbers. An example of continuous data is a person's height. A person's height can be a whole number or it could be a decimal. Somebody could be 35.5 inches tall. So it's continuous data. In the next slide, you're going to come up to the board and label the data, either discrete or continuous. The first example says James sold CDs for $5 each after he paid $15 for equipment and supplies. The equation y equals 5x minus 15 shows the profit James will make from selling CDs, where x is the number of CDs and y is the profit he will make. James has 20 CDs to sell. Find the domain and the range of the function. So the first question we have to ask ourselves is my x value an example of discrete data or continuous data? If you go back to the problem, it says that my x value stands for the number of CDs. Is number of CDs, can it only take on whole number values or could it be decimals? The answer to that question would be that it's only whole numbers. We can't buy parts of CDs. So this data is discrete data. Since it's discrete data, when we write our domain and range, we're going to use our squiggly notation, as I like to say, to do it. So, in order to find our domain, we have to go back and read our problem and figure out what x values are included in our word problem. It says, James sold CDs for $5 each after he paid $15 for equipment and supplies. The equation y equals 5x minus 15 shows the profit James will make from selling CDs, where x is the number of CDs and y is the profit. If James has 20 CDs to sell, find the domain and the range in the function. So if I go back and look, my domain is my x values, and it's talking about my number of CDs. In my problem, it tells me James has 20 CDs to sell. So when I write my domain, I am going to write it. I could start with having 0 CDs. I could have 1 CD. I could have 2 CDs. I could have 3 CDs, 4, 5, all the way up to 20. So when I write my domain, I write my squiggle bracket 0, 1, 2. I'm going to put 3 dots, which means I include all my numbers from 2 to 20 in there. So that's my domain. To find my range, I am going to plug my domain values in to my equation that's given here, which is y equals 5x minus 15. So to do that, I would have y equals 5. My first value in my domain is 0, so I'm going to plug 0 in for x minus 15. So you work that out. 5 times 0 minus 15 is negative 15. Negative 15 is the first value in my range. Then I go to my next domain value, which is 1. So I'm going to have 5 times 1 minus 15. I work that out. 5 times 1 is 5. Minus 15 is going to give me negative 10. That's my next value in my range. Then I work out 2, because that's the next value in my domain. So I have 5 times 2 minus 15. 5 times 2 is 10. Minus 15 is negative 5. And then my next value that I have, I'm including all of them, but I'm going to stop at 20. So I'm going to have y equals 5 times 20 minus 15. 5 times 20 is 100. Minus 15 is going to equal 85. So my numbers in my range are going to be negative 15, negative 10, negative 5, dot, 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 all the way to 85. I use my squiggle brackets because this is an example of discrete data. The next example we're going to look at is example 2. It says Joe had a summer job that pays $7 an hour and he worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S equals 7H, where S is his weekly salary and H is the number of hours he worked in the week. What is the domain and range and context to the problem? So the first thing we have to do is decide if this is discrete or continuous data. To do that, we look at our X value. However, in this problem, we have variables of S and H. So we have to figure out if S is our X value or if H is our X value. If you look at your equation, S equals 7H. H is going to be my X value, and S is going to be my Y value. Because H, whatever number I put in for H, your S value is going to depend on that, which means H is my X value, that's what I put in, and S is my Y value. So I have to determine if hours is continuous or discrete data. When you think about continuous or discrete data, you have to think, can you have part of an hour, or does it hours only come in whole numbers? The answer to that question would be that you can have part of an hour. You could have 1.2 hours. So this is an example of continuous data. Since this is continuous data, we are going to use our inequality notation or our sandwich inequality to write our domain and our range. So I'm going to go back to my problem and I'm going to look to see what information it gives me about my X value or my H value in this case. It said Joe has a summer job that pays $7 an hour and he worked between 15 and 35 hours every week. H is my X value. In this sentence, it tells me that I worked between 15 and 35 hours every week. So that is going to be my domain. My domain is going to be 15 to 35 hours. So when I write it, I'm going to write 15 is less than or equal to X is less than or equal to 35. I use my inequality notation because I have continuous data. In order to find my range, which in this case is my S value, I have to plug my domain into my given equation. So my given equation is S equals 7H. So where I see H, I'm going to plug in my first value of my domain, which is 15. I'm going to multiply 7 times 15, which is 105. Then I'm going to plug in 35. So I'm going to have S equals 7 times 35 because that's my other domain value that I have. So when I multiply 7 times 35, I get 245. So then I write my range. When I write my range, I use my inequality notation because it is continuous data. So 105 goes first. Less than or equal to Y is less than or equal to 245. And that would be your answer. Example 3 on your guided notes says, Hector's Service Club is raising money by wrapping presents in the mall. The function f of x equals 3x describes the amount of money in dollars the club will earn for wrapping x presents. They only have enough wrapping paper to wrap 1,000 presents. What is the domain and range in context to the problem? So we have to figure out if this is discrete or continuous data by looking at our x value. So we go back in our problem and we're going to look to see what my x value stands for. It says that the club will earn wrapping x presents. So x stands for the presents that we wrap. So when you think about presents, can you wrap part of a present? The answer to that question would be no. I have to wrap 1 present, 2 presents, 3 presents, etc. So this would be discrete data. Since it's discrete data, when we write our domain and our range, we're going to use our squiggly brackets. For your domain, we're going to go back and reread the problem and see what it tells us about our presents. It says, Hector Service Club is raising money by wrapping presents in the mall. The function f of x equals 3x describes the amount of money in dollars the club will earn for wrapping x presents. They only have enough wrapping paper to wrap 1,000 presents. What's the domain and range? So if you look into the second to last sentence, it says they only have enough paper to wrap 1,000 presents. Okay, so when I write my domain, I could wrap 0 presents. I could wrap 1 present, I could wrap 2 presents, I could wrap 3 presents, all the way up to 1,000, because it says I have enough wrapping paper for 1,000. So when you do your domain, you're going to use your squiggly bars. You're going to have 0, 1, 2. To save time from writing all the numbers to 1,000, we're going to put our 3 dots to signify that, all the way up to 1,000. Then to find your range, you have to use your function that's given, which is f of x equals 3x where I see x, I'm going to plug in my domain, which my first domain value is 0. So 3 times 0 is 0. So the first number in my range is going to be 0. Then I'm going to take and fill in my next x value, which is 1. So I'm going to have 3 times 1. 3 times 1 is 3. So my next value in my range is 3. Then my next x value is 2. So I'm going to plug 2 in for x. So I'm going to have 3 times 2, which equals 6. And then I'm going to go up to 1,000 because that's my last number that I have written. So I'm going to have 3 times 1,000, which gives me 3,000. So when I write my range, I'm going to use my squiggly brackets because I have discrete data. I'm going to have 0, 3, 6, and then I'm going to add 3 dots to show that I've got all the numbers all the way up to 3,000 included in my range.